Welcome back everyone to another digital SAT math video with Edbridge Scholars. Today we'll be talking about how you can evaluate statistical claims, and some of the key concepts would include observational versus experimental studies, random assignment, confounding variables, and bias. The first thing we need to clarify is the difference between an observational study and an experimental study. And this difference essentially boils down to whether or not the researcher is intervening in the process when they're collecting data or when they're collecting data from a random sample. For example, if we walk up to 100 people randomly chosen in a school and ask them if they had breakfast today and if what their GPA is, and then we see a certain kind of correlation that people who actually eat breakfast tend to have higher GPAs, we can only establish that as a correlation or association, but we cannot claim causation. That is, we can't claim that eating breakfast can lead to higher GPAs. So that's an observational study. Whereas in an experiment, we have to assign treatment. So in that case, we can once again randomly sample 100 people from the school, but now we assign 50 of them to a group where we have the students eat breakfast for a semester, and we assign the other 50 to the other group where the students don't eat breakfast for a semester, and then at the end of the semester we can compare their GPAs, and that's how we can establish a causation. If it ends up being that the people who ate breakfast actually had a statistically significant difference in GPA, they had significantly higher GPAs, then we can establish that causation, that eating breakfast can lead to better GPA. The next thing you need to be aware of is what a confounding variable is. So confounding variable is when we try to explain something based on an observational study, but actually there's a third variable that is related to both the explanatory and the response variable. For example, we can collect data and we can maybe show that around the same time in summer, actually ice cream sales and drowning both increase. So whenever, like if we just see all throughout the year, the number of drownings per month and the amount of ice cream sales, we'll see that actually the number of ice cream sales and the number of drownings, there is a correlation between them. But that doesn't mean that selling more ice cream causes people to drown. Actually, there's a third reason, which is heat, that ties both of them, and it's heat that's causing both of them. So in this case, heat is our confounding variable. Another thing you need to be aware of is a selection bias. So sometimes we may select a certain group of people, which leads to other groups being excluded. So if we're trying to see what kind of coffee people in New York like, but if we only survey people who buy Starbucks, then we're excluding people who may be buying coffee from other brands who may not be buying coffee from Starbucks. Sometimes you can also have a response bias if you're posing a leading question. That is, if you're going up to people and you're pushing them to give one answer over the other. So that can cause a certain kind of bias, which is known as response bias. You can also have a non-response bias, and you can also have a voluntary bias where you're essentially taking opinion from people who'd volunteer to give opinions, and what that does is only the people who have strong opinion on that matter end up giving their opinion. So your opinions tend to be more on the extreme end. So there is a certain kind of bias there because you're only getting data from people who care deeply about that issue. So really, there's three requirements for causation. You have to have random assignment. It has to be a controlled experiment. You're going to control your confounding variables. You're going to make sure you don't have confounding variables messing with your study. And you're going to have the confound ruled out. And the experiment has to be controlled. So you're going to make sure you don't have any other variable there that's also interfering with the process. So for example, if it's not randomly chosen, or if there's a third factor that's interfering there, if we end up choosing for the group that eats breakfast, if we choose the top 50 students of the class and the group that doesn't eat breakfast, if we choose the bottom 50 students of the class, in that case, that experiment is no longer controlled because it's not a random assignment, and thus there's a third variable that's interfering, that is the student's current class rank, and there are also like several confounding variables that may be causing those effects. So you have to have random assignment, and the experiment has to be controlled, so only the variable that we're checking for has to be the variable that differs between the control group and the testing group. And then finally, we have to make sure there is no confounding variable. We can look at a practice question here. A city council surveyed 500 dog owners about converting a field into a dog park. The majority favored it. What's true about the survey? The sample, it shows the majority of residents favor it. More dog owners should have been included. It should have consisted entirely of non-dog owners, or the sample is biased because it's not representative of all city residents. So in this case, as we can see, they only took opinions from 500 dog owners. So then we have a selection bias where we're only getting opinions from people who are dog owners, so we're excluding people who are not dog owners. So that means our sample is not representative of people of the city population, and therefore the sample is biased. So they'll always try to trick you with answers that claim causation from these observational studies. So you have to be aware of that. You have to make sure that you can separate an observational study from a controlled experiment, and always check, was there random assignment? If there was no random assignment, if this was just simply observation from random samples, that's an observational study, and you can never establish causation from those. As always, keep practicing, keep improving, and I'll see you in the next one.